Okay, welcome to lesson number 9. This is lesson called is self-parking. So this lesson is based on lesson number 8. We're going to use the code that we built in lesson number 8, and we're going to adapt it to teach the mbot how to implement something that I call the parking spot strategy. So it is important that if you didn't take a look at lesson number 8, you go back and learn how to do that one before, because we're going to use the code that we learned in that section. So, well, for the presentation of this lesson, it's very brief. We're only going to add what we learned from lesson number 8, and we're going to teach the mbot to implement something called parking spot strategy. In this case, what we have to do is that we're going to use these three elements of the mbot: the LED lights, the line follower, and the ultrasonic sensor, and we're going to use them and to teach the mbot how to park. The objectives of this lesson are very similar to what we did in lesson number 8. The mbot should be able to use the line follower. The mbot should be able to detect if there is an object and stop and react adequately. However, in this case, that's different to what we did in lesson number 8. If there is a missing section in the path, we're going to implement the parking spot strategy. The parking spot strategy basically checks both sides of the road to see if there is a parking spot available. First, it's going to check right. It's going to use the ultrasonic sensor to verify if there is an object ahead. If there is, it's going to check left, and if there is in that one as well, it's going to go back to its original position and move forward. I'm going to use that in the analysis of this lesson. However, for now, all you have to do is try to picture that in your head. If there is no parking spot available, the mbot is going to run in circles infinitely through the circuit until a spot becomes available. However, once there is a spot with no object in it, the mbot is going to park there. All right. So now, most of the code that we are going to use, it's obtained thanks to what we did in the last lesson. However, one important part of this project is that we require a little bit of experimentation. The mbot, the motors that it uses are not very precise when it comes to turning. So in order to calculate how much speed and time it's necessary to turn 90 degrees to the right, 180 degrees to the left, we're going to use a little bit of experimentation. What you have to do in this case is that you have to connect your mbot to your computer, set up a speed to any number you want. It can be 100 for example, and then tell the mbot to turn for 3 seconds and write down how many degrees approximately that was. And then depending on that, you can reduce the time or the speed until you reach 90 degrees. Once you have your 90 degrees to the right, you can multiply that times 2 to calculate 180, and then repeat to the right to return to the original position. So to explain a little bit what we're going to do with the parking spot strategy, I'm going to use this diagram. So basically, this is if you picture the arrow as the mbot, this is the original position, and let's say the mbot is following the line that it's right here. It's going to move, and once it reaches this missing section of the path, it's going to turn right. It has to turn right because the ultrasonic sensor is located at the front of the mbot. It's going to turn right, check for an object. If there is an object, it's going to turn 180 degrees to the other side. If there is no object, of course, it's going to park there. However, if you think that there is an object right now, what the mbot would do, let's go back to its original position, move forward, and find its way back. And if this was a circuit, it would keep going and going until one of these two spots was available. So that's basically what we're going to teach the input how to do. As I told you, to calculate how much speed and how much time the input is required to turn 90 and 180 degrees, you're required to do it through experimentation. It's a little bit tedious, especially because the amount of degrees the input turns can also change based on the batteries that you're using. But anyway, it is a step necessary for this program. All right, so now for the diagrams that we're going to be using. All right, so as you can see, this is very similar to what we did in the traffic simulation program. First of all, our program has to make a decision. It's going to wait until a button is pressed. Once it's pressed, we're going to implement the calibrate function that we built last program, where if you remember, the input turns to the right in its place until it finds its path. And we're also at this point going to obtain a line follower value. At this point we're going to get into an infinite loop, as you can see. Basically this point A, right now I don't have the function C, but the output of every function B and function C goes to A eventually, which creates an infinite loop. Once the M button is calibrated, it's going to obtain a line follower value where it's going to turn right or left depending on the path. And similar to what we did in traffic simulation program, at the same time it's going to be obtaining the ultrasonic sensor value and making the decision where if the ultrasonic sensor value is less than 6, it's going to set the line follower value to something. In this case, this is different from what we did to the traffic simulation program because it's going to set the line follower value to 4. If you remember from last time, we set it up to 3, but in this case we want to do it because two different things are going to happen if there is an object ahead and if there is a missing section in the path. So I just changed the value of the line follower to something else so that the input is capable of doing two different things if there is an object in the path and if there is a missing section. But in this case, if there is an object in the path, we're going to set it up to 4. And once the value, if you remember what happens for each value of the line follower, if it's 0, it goes straight. If it's 1, it turns left. If it's 2, it turns right. And then it goes back to here where we basically are using that infinite loop. However, the value 3 was where we set it up for the input to stop and simulate like a stop sign if there was a missing section in the path and if there was an object ahead. However, in this case, if there's an object ahead, it's going to set it up to 4. And it's going to go to this section right here, which is section B, where it's basically the same strategy that we did in the last program. It stops moving, executes the light stop signal 3 times, and then it runs forward and until it finds its path, and it sets the line follower value to less than 3. It could be 0, 1, or 2, and it basically starts following the circuit again. It goes back to our infinite loop. However, what's going to change is what happens if our value is 3. And our value is 3 once the mbot didn't find any path. And this is basically what we're going to do. This is the part that it's new. This section, it's our parking spot strategy. So once the mbot did not detect any path using the line follower, it's going to trigger this, which is basically it's going to stop. If you remember how to stop the mbot, it's going to set the speed to 0, and depending on the experimentation for you, it's going to set then the speed and the duration to the proper settings to turn 90 degrees to the right first. Then it's going to check for an object using the ultrasonic sensor. and then it's going to make a decision where if there's no object ahead, it's going to run forward. I set it to 70 for the speed for a certain duration, and then it's going to stop like it's parking. However, if there is an object ahead, it's going to turn 180 degrees to the other side and check again if there is an object, and then another connector just to do this horizontally. If there is an object ahead, it's basically going to do the same decision. If there's not, it's going to park, but if there it is, it's going to turn right 90 degrees again, and then it's going to run forward until it finds its path, and then we're going to go back to point A, which is here. So that's basically the analysis of our program. So now we can get started with the coding. So first here. All right, so if you remember, this is basically the code that we had from the traffic simulation program, and we're just going to adapt it to implement the strategy that I just explained before. So we can keep most of it. We're going to keep all this. If you remember, this is what's running. So first thing we have to do is set up our speed to 70, and then we're also going to set our object ahead to the ultrasonic sensor on port 3, and then we're going to wait until the button on the board is pressed. Once this has been pressed, we're going to trigger this function that we call calibrate. This function is right here, and the objective of this function is to find a path. We set up first the value to the line sensor to something impossible, which is 99, but it is a known value. And what it's going to do then is that it's going to turn to the right at 70 until and reading the value of the little line follower until the value is less than 3. Once it goes that, it's going to run our traffic simulation, and we're gonna go here to this section of the program where once again we can set the object ahead to the ultrasonic sensor value. This is we have to include this here. It's going to be running infinitely, and we're also going to set up the line sensor value as well. And then in this case we are going to change this right here, which is if the object ahead is less than 6, we're going to set up this to 4. All right, if you remember, that's what we did in our diagram, and the rest is going to stay the same up until 3. However, we're going to change the name of a few things. First of all, we're going to take this out of here, and we're going to create something. Oh, I forgot this time to go to Arduino mode, so let's do that. What we're going to do here is that we're going to create a new function, if you remember, and we're going to call it find parking. All right, that's right here. And in the case of my robot, I'm going to set speed to, I set it to 93 in my case. These values are the ones that you have to figure out through experimentation. Yes, 93. And in my case, I think I don't have this variable yet, but let's check. Set, yep, I don't. So I'm going to call this duration. All right. And oh, the duration value in my case was 0.73. So and these two values I got through experimentation, and basically they mean that it takes the about 73.73 seconds at speed 93 to turn 90 degrees to the right. Once it does that, what I'm going to do we're going to use this to stop your mbot. So all you have to do is put run forward at speed 0. Then we're going to wait 1 second. Then we're going to use this again to turn right at speed here, speed. All right, so that's how we're going to turn 90 degrees to the right. So once we do that, we're going to wait 1 second, because why not? And then the mbot, we're going to create another one, and we're creating this one, which is called check for object. I don't think we have one that does that. Yep, we don't. Right. So what we're going to do now, here in this check for object function, it's that the mbot is going to set object ahead to the value received by the ultrasonic sensor on port 3. We're also going to make sure that the mbot is not doing anything moving. We're going to wait a little bit, in this case not as much, 0.5. Alright, what I did here, it's another decision, which is if then, if, and then we're going to use a comparison, which is if the object ahead is more than 40. And what we're going to do, it's that the mbot is going to run forward at speed 70, actually 70, and then wait. So let me explain this part. So basically, once the mbot is running, once it runs this function, here, actually I see that I didn't call it, find parking here. Okay, so the mbot started all the values, calibrated, and then it's running here all the traffic simulation loop. So once there is a missing section in the path, which is value 3 if you remember, it's going to find parking right here, where it sets up these two values to the appropriate values to turn right 90 degrees. It's going to stop, and then it's going to turn right, and then it's going to check for an object here. Yes. And what it does when it checks for an object is this, where it's going to read the value read by the ultrasonic sensor, and then it's going to run forward. Well, it's going to stop and wait a little bit, and once it analyzed if there is an object ahead, in this case I set it up to 40. I mean, you could set it up to anything you want depending on how far you're putting the parking spots, of course. However, once it's more than 40, then if it's more than 40, that means there is no object ahead, so it can move forward, in this case at speed 70, and then it's going to do that for, I think I said 1.8 seconds. So it's going to run forward at speed 70 for 1.8 seconds, and then it's going to run forward at speed 0 to stop and wait for 1,000 seconds. So basically the mbot stops here for 1,000 seconds, giving you enough time to pick it up, and basically that's the end of the program. Depending on if there is an object ahead, and this is going to happen right after the find parking program. However, we also need to call this one find way back here, because if this wasn't true, if the object ahead was bigger, I mean smaller than 40, this is not gonna fire. So then it's gonna go to whatever it's here. In this case, we're going to call find way back, which is this, where it finds the circuit again. But however, we're not done with the find parking strategy, because after we checked for the first object, we have to basically copy this set of code, which is duplicate, paste. In this case, let me actually delete this part. Oops. Delete. There you go. I only changed this value. Set duration to 1.45. And then instead of turning right, it's going to turn left at speed. Then it's going to, oh, actually, this part right here, it's important. There you go. Yes. Check for object. Yep. So this one actually, because this right here, it's for how long it's doing this action. So what's happening here, it's that it has to do this turn right at this speed for a certain duration. That's what's going on here. So it couldn't be any value, it had to be the duration that we're doing. Lastly, so after it turn left and for a certain speed, we are going to stop, of course. Have to delete that one. Stop and wait 3 seconds. Yep. And then check for an object again. This is going to fire again. And if none of that was true, duplicate, paste. Okay, we're not gonna need everything here. Delete. We're going to set the duration to 0.68. Again, these values I got through experimentation. And then instead of turning left, it's going to turn right. To delete. Oh, wait. There you go. Delete. Yep. Turn right at the same speed for this amount of time during this duration. To turn right, and it's going then to find its way back. So, however, the program is going to finish whenever it finds a parking spot, thanks to this function right here. All right. So lastly, what we have to do now is do one more conditional here, because this is what's going to happen if there is an object ahead. Not this. Delete. Delete. I think this one. Yep. Yeah. So once again, let me explain. Let's trace it once more all the way back. Set up your variables, then initialization, then wait until your button is pressed. Once it's pressed, calibrate. Once you calibrate it, run forever the traffic simulation, which is right here, where you read the ultrasonic sensor value, the line follower value, and then if there's an object ahead, you're going to set the line sensor value to 4. which basically triggers your crosswalk pause. If you remember, it's what we did, turning the LED lights red on and off for 3 times, I think. Oh, 3 times. There you go. And then it's going to find its way back. Just keep following the circuit. If the value is 0, 1, or 2, it's going to do the appropriate thing, turn left, right, or run forward, depending on the circuit. However, if there's a missing section, we're going to trigger our find parking strategy, which is right here, where we set up the speed and duration to the proper values, and stop the mbot, wait for a second, and then turn right for the correct amount speed and duration, and check for an object where we read the value on the ultrasonic sensor. We stop for that, and then depending on if there is enough space for the mbot to go ahead, it's going to move forward for this time and this duration, and then it's going to stop for 1,000 seconds, giving you enough time to pick it up or turn it off. However, if this is not true, it's going to go back here, set the duration again for the proper amount of time, and turn left 180 degrees using these, and it's going to stop, wait a few seconds. Let me reduce this once more. We don't want to make the program too lengthy. Check again for an object, evaluate if there is an object or not, and if there is, go back for the correct duration to turn back to the circuit direction, and then once that it's over, it's going to find its way back again and follow the circuit, and this is going to run infinitely until there is an available parking spot, which is here. Yep. So that's basically all you have to do. Last time, you're going to connect. In this case, remember, serial port, mine's not connected, but once yours is, just upload to Arduino and you're gonna get to go. And next up, just a few video on what it looks like.
Okay, so as you remember, that's the track that I built, and I used books and those paper towels to represent objects. Once there's a missing section, the mbot turns left and right, goes back, finds its way, turns right, checks for an object, turns left, checks for an object, and since every parking spot it's used, it turns back to its path, and then it follows the circuit. Just to show that all the other elements are also available, I place that object in the circuit to show that the stopping strategy is also implemented. I think this one was five times repeats the sign. However, once the path is clear, goes back, keeps following the path. Once again, it takes a little bit, but it's going to turn right, check, turn left, check, and nothing's available, so go back to your original path, follow, find your path, then it's going to turn right, it's going to be like, hey, there's a parking spot, and it parks basically, and that's the end.
Okay, so now that we're done basically with all the mbot programs, I just want to tell you congratulations for finishing this very basic course. If you liked it and if you think this is something you'd like to do, programming, I totally recommend it to you. Programming is something that has a lot of potential and a lot of fields. Um, I remember when I started, I thought I was going to be making video games and that was my passion. However, the potential of programming is much more than just that. Um, just to mention a few things of what you could do with programming, you have, for example, Python, which is this coding language. You could use it as well with the mbot. However, if you're more interested into web programming, you could get into JavaScript, or you also could learn HTML. And of course, if you learn HTML, you'd have to learn CSS. That's if you're into web programming. If you're into other technologies, you could learn a little bit of Java. You could learn C++ or C Sharp. It depends on you what you want to do. But my advice is to never stop coding. And I hope you enjoyed this small introduction to programming. and I'll see you next time.